Hey everyone, and welcome to The Explainer. I am super thrilled you're joining me today because, well, we're looking at something that is fundamentally reshaping the economics of high-performance computing. If you've been paying any attention to the AI boom, you know we're facing a massive data center cost crisis right now. And the main culprit? Heat. So today, we're going to tackle this problem head-on by looking straight at the thermal engineering math. We're going to break down exactly why Supermicro's direct-to-chip liquid cooling, specifically their DLC-2 architecture, is an absolute game changer that dramatically saves costs across the board. All right, let's just jump right in. Here's our quick roadmap for today. We're going to hit 5 key areas. First, the rising heat problem. Second, we'll explain the Supermicro DLC-2 paradigm shift. Third, we'll measure the exact cost savings. Fourth, we'll look under the hood at the hardware. And finally, we'll see exactly how this accelerates your ROI. Okay, kicking things off with Section 1, the rising heat problem, and the true cost of the AI revolution. So I want to pose this critical question to you right out of the gate. How on earth do we cool the AI revolution without completely blowing the budget? As data centers push to meet these crazy new demands for compute power, the financial and operational stakes have literally never been higher. We're asking our infrastructure to do more than ever, and you know what? That comes with a very real, very literal thermal cost. Look, the core issue here is pretty simple, but it is severe. With every single new generation of GPUs and CPUs, the thermal design power, or TDP, is just skyrocketing. Sure, we're getting way more performance per watt, but the sheer volume of heat blasting off these components is accelerating way faster than any of our traditional air-cooled solutions can handle. I mean, trying to push chilled air over these hot chips, it's fundamentally unsustainable and honestly, incredibly expensive at the facility level. So we urgently need a better way to remove heat from the server to the rack and out of the entire data center. Which brings us nicely to Section 2, Supermicro DLC-2 Explained, and the whole paradigm shift to liquid. Let's actually walk through how this works in practice, because it's really elegant. Liquid cooling is just physically way more effective at removing heat than blowing air over a chip. Why? Well, water is just a vastly superior thermal conductor. In Supermicro's system, you have supply liquid, which is literally just ambient temperature water flowing directly over the hot components. The heat transfers straight into the liquid, warming it up by maybe 5 to 10 degrees Celsius. Then that warmer liquid is pumped out to an external water tower to be cooled down, and the whole cycle just repeats. It is a brilliantly efficient, closed-loop physical engineering process that simply carries the heat away. All right, let's follow the money in Section 3, measuring the cost savings, or what Supermicro calls the 4 UEs. First up is power usage effectiveness, or PUE. Check this out. If we assume a traditional air-cooled data center runs at a PUE of about 1.5, a liquid-cooled setup using DLC-2 operates at an assumed PUE of 1.1. When you run that math, your ratio is roughly 60%. What does that mean for you? It translates directly to a massive 40% reduction in power consumption. Think about that. You are getting the exact same IT performance for nearly half the energy footprint. Moving right along, we have space usage effectiveness, SUE. Liquid-cooled servers are purposefully designed to be incredibly compact. Because you aren't dealing with giant fans and huge airflow channels taking up all your space, you can pack way more compute in. In fact, looking at GPU density, a liquid-cooled rack is about 60% more dense than an air-cooled one. You are saving extremely valuable data center real estate and significantly dropping your rack and cable counts. And to really visualize exactly how that SUE metric is achieved, let's look at the old format versus the new. To hit a specific performance mark, an air-cooled system needs a massive 10U server. The exact equivalent in a liquid-cooled system? It's just 4U. That's a space ratio of 40%, which leaves you with 60% more room in your racks. It's just a stunning visual representation of efficiency, right? Okay, next is water usage effectiveness, WEU. Now, you might be thinking, wait, a liquid-cooled data center uses less water? Yeah, absolutely. In air-cooled facilities, they use a ton of water to run power-hungry chillers for the HVAC. But with DLC-2, the water cools the IT systems directly. By using warmer ambient water instead of highly pre-chilled water, you basically eliminate the need for those massive chillers entirely. That drastically cuts your water consumption by about 40% compared to traditional air cooling. Finally, we bring it all together into money usage effectiveness, or MUE, which basically is your total cost of ownership.
When you stack up 40% less power, 60% more density, and 40% less water, those operational expenditure savings compound incredibly fast. Over time, building with Supermicro's DLC-2 tech generally leads to a 20% lower overall total cost of ownership. That is huge.
So let's pop the hood for Section 4, the hardware driving efficiency. So what's actually doing the heavy lifting? It's powerhouse hardware like the 4U SYS422GS-NBRT LCC liquid-cooled optimized GPU server. This thing is an absolute beast, built for cutting-edge compute. We're talking dual processors up to 500 watts each, plus an NVIDIA HGX board with 8 GPUs that can pull up to 1,000 watts per GPU. And the front I/O design is specifically engineered for better thermal performance, cramming all that extreme power into this dense, tiny 4U form factor. And there are some massive innovations making this tick. First off, they're using cold plates that cover almost everything. CPUs, GPUs, PCI switches, DIMMs, power supplies. That captures up to a staggering 98% of the heat. To handle all that, Supermicro introduced new in-rack coolant distribution units, or CDUs, that remove 250 kilowatts of heat per rack. That's a 150% capacity increase. Plus, these servers take inlet water up to 45 degrees Celsius, crushing the need for chillers. They use hybrid cooling towers for seasonal shifts. And honestly, my favorite part, because there's barely anything left to air cool, the internal fans spin way slower, dropping the noise level down to a super quiet 50 decibels. It's quieter, it's denser, and it's wildly more efficient. Which leads us to our final part. Section 5, accelerating your ROI and the ultimate time advantage. Okay, get ready, because this is honestly the operational mic drop moment. Supermicro's data center building block solutions, which is everything from the servers to the piping and software, give you the best time to market in the industry. A normal liquid-cooled deployment usually takes about 12 months. But with Supermicro, your time to online shrinks to just 3 months. That's practically overnight in data center time. To quote the source directly, Supermicro provides an advantage to our customers by accelerating the return on their infrastructure investments sooner. I mean, getting your high-performance compute online 9 months faster, that's not just saving you massive headaches, that translates directly into immediate, accelerated revenue generation for your business. So I want to leave you with one final really provocative question to think about. Is your current data center bleeding money on air cooling while you're stuck waiting 12 months to deploy? The math is pretty undeniable here, folks. With Supermicro's DLC-2, you cut power by 40%, you pack 60% more compute into your racks, and you get online 9 months faster. The paradigm shift is absolutely here, and it is liquid. Thank you so much for joining me for this explainer. I really hope breaking all this down empowers you to rethink your own infrastructure strategy. See you next time.